So hi everybody, I'm here at the American Geophysical Union meeting, and I'm here with Natalie Monacci from the College of Fisheries and Ocean Sciences here at UAF. Natalie, you have a presentation here on ocean acidification. First thing, what is ocean acidification?
Ocean acidification is when the ocean is absorbing carbon dioxide from anthropogenic sources. So as the increase of atmospheric carbon dioxide increases, more is being taken up by the ocean.
Gotcha, okay. And I understand that Alaska has some unique things about our ocean water that makes us maybe a little bit more susceptible to this.
Yeah, there's kind of three areas that make Alaska more vulnerable to ocean acidification than other areas. One is that we're at a high latitude and our waters are just naturally colder. So cold water can absorb and hold on to gases better than warm waters can. So an example of that is your soda pop. So your soda can hold on to those carbon dioxide bubbles that fizz better if it's colder than if it's warmer. So in Alaska we have colder waters, we're able to hold on to more carbon dioxide.
Right, okay.
A second area where we're unique is we're at the end of the global circulation of the oceans, and so older water is in the Pacific Ocean than the Atlantic, and it is holding more carbon dioxide. And so as that water comes up and around Alaska, we have more carbon dioxide.
Awesome. And then the third factor is?
We have a lot of fresh water in Alaska, and fresh water can also change the chemistry around Alaska and affect ocean acidification. So we have cold waters holding on to more CO2, we have older waters holding on to more CO2, and we have a lot of fresh water. This is all driving pH down. So the pH of the water is a relative term when we're talking about acidification. It doesn't mean that the ocean is now an acid. It just means that it's more acidic than it has been in the past.
Interesting. And so your poster mentions clam, cod, and crabs. Why should we, why does this matter? What does a more acid ocean do to these species?
So first, we like to monitor ocean acidification, and then once we get an understanding of the values of ocean acidification that we see around the state, we want to take those values and say, how does it affect an important species? So one important species is clams. They're important culturally. They're an important subsistence species around the state. Lots of different communities rely on them for food. So we're really interested in learning about how acidification will affect them. Crab is both an important subsistence and culturally important species as well as a commercial species. And cod the same way. So when we look at different kinds of animals and where they live around the state in the water column, some live in the sediment, understanding the vulnerabilities of all different kinds of species is important as to how Alaskans will remain resilient to change.
So your work is monitoring this stuff and understanding it so we kind of know what to expect next.
Yes, so we hope to maintain our current long-term monitoring stations around the state to understand the effects, the intensity, and the duration of ocean acidification around the state. And that's kind of the basis of our chemistry focus. And a lot of our biological focus is the physiological responses on different species.
Interesting. Well, thank you so much, Natalie.
Thank you.